Ever exciting and fascinating with chemistry. We're looking at our last gas law, which is the ideal gas law, definition of ideal gas law. Behavior gas in a perfect or ideal state. Now, this differs from combined gas law because we only have one set of conditions. So if we take our combined gas law value and add what's called the Avogadro's law, which is also in an inverse relationship to volume, we end up with PV over NT is equal to R, where N is the number of moles. R is the ideal gas constant then, and that value is either 0.0821 liters atmospheres per mole Kelvin or 8.31 liters kilopascals per mole Kelvin. All right, we can solve that up to make an even equation by equals PV equals nRT, or my old high school chemistry teacher, Mrs. Mary Bunny Bunnell, used to call it Pivner. Okay, this is the ideal gas equation. All right, so let's take a problem. Find the volume of gas of 1.289 moles of a gas at 75.09 degrees Celsius and a 1.087 atmosphere pressure. So we only have one set of conditions, so this is not combined. So we're going to do Pivner, PV equals nRT. We have our values, PV, nR, and T. Pressure is 1.086 atmospheres. Volume is unknown, find the volume. Moles, 1.289 moles. R, we're going to use the 0.0821 since we're in atmospheres. So we're going to use this constant. And temperature is 75.9 degrees Celsius, and we don't want Celsius. We never want Celsius, so we want Kelvin. So we had 273, and we get 348.9 Kelvin. All right, so we're solving for V. We got V multiplied by P, so we're going to move P to the opposite side, divide both sides by P. So V is equal to nRT divided by P. Put our values in, 1.289 moles times 0.0821 liters atmospheres per mole Kelvin times 348.9 Kelvin all over 1.0876 atmospheres. All right, my moles cross out, my atmospheres cross out, my Kelvins cross out. Leaving with liters, my answer is 33.95 liters. Now, we take our Pivner, PV equals nRT, and we can derive the equation PV m is equal to mRT. We use this if we're looking for mass. How do we do that? Well, moles is mass over molecular weight. So our second ideal equation is PV mW is equal to mRT. So here's an equation. Calculate the mass of 13.55 liters of carbon dioxide gas at 100.8 kilopascals and 23.9 degrees Celsius. Okay, we'll do that one in class. All right, we can also take that equation and change to a third equation, and we can do that when we know the density is equal to m over v. So we move volume to the side, divide m over v, and get density, and we get pressure times molecular weight is equal to density times r times t. All right, so determine the density of nitrogen dioxide at 755.8 torr and 31.2 millimeters 9 degrees Celsius, and we're using our equation PMW is equal to DRT. All right, we'll do that one in class as well. Very good. So we have these two. Copy these down. We'll do these in class. Any questions, let me know. Take care. Be good. Bye.